Well, I'm not sure anybody fully understands the solar cycle, but um, the most popular theory is one that was developed some 40 years ago. And they, what the solar cycle is that you get a period of many sunspots followed by a period of few sunspots, and the numbers of sunspots vary sort of sinusoidally on a 11-year period. Uh, there's another cycle that's 22 years on average. It's not fixed. This is sort of an average time, but the sun's magnetic field is actually changing polarity. So it's you go through solar maximum, and the sun's field is very unorganized, and as you come into solar minimum, it's very organized and it has one polarity. It's like a dipole field. And then you go back to solar maximum, and the field is very unorganized, and then it emerges with the opposite polarity. And the theory of how that happens is a little complex. I find it amazing that it happens so regularly, but the magnetic field of the sun has to be generated very near the surface, and the theory predicts that it's the results of differential rotation. The rotation at the equator is faster than at the poles, and so you wind up this magnetic field. Field lines get compressed together, break apart, and then you get this irregular field, and then it reemerges in the opposite polarity. I guess I've always liked nature and natural phenomena. I think as I got into science more, I liked the people that I was working with. I liked the intellectual activities and the kinds of people that were involved in these. We had similar kinds of interests, and so they were interesting to be with. Some people do science that look at the big picture. Some people look at the minutia and look at the details. So there's a lot of room for many different types of people to contribute, and the job has a lot of variety in it in itself. So you're not doing the same routine thing all the time. So I guess those are aspects that I like.